Hey, this is Professor Perez from Saddleback College. Today we're going to work on integer exponents. But of course, we can't have a class without Charlie, so let's make sure he's ready to go. Hey Charlie, how's it going? Yeah, today we're doing integer exponents. That's right. Now remember, if you're having a hard time with this, you can always come back and do it next semester. That's right, yeah. Remember, yes, before you ask, this stuff will be on the test. Anyway, let's get going here. The first thing we're going to talk about is some differences between, let's see, exponents and multiplying a number by a variable, because that tends to give students a problem. So let's go ahead and list our first thing right there. There we go. So what we have here is 3x and x cubed. So Charlie, what does 3x mean?
X plus x plus x.
Okay, what does x cubed mean?
X times x times
That's
x.
right. Very nice, Charlie. I guess you're learning something. So let's go to the next one here. What does 5a mean?
A plus a plus a plus a plus a.
Very nice. Okay, and then a to the 5th power?
A times a times a.
That's right. Okay, let's get a little bit more complicated now. Let's do a 3xy. Suppose you have 3xy's, Charlie. What does that mean?
Xy plus xy plus xy.
Very nice there. Now look at this next one here. Xy cubed. Now remember, the xy is in parentheses. That means that the xy is the base. So if you have xy raised to the 3rd power, it means xy times xy times xy. There it is listed up there. Now remember, that simply means x times y times x times y times x times y. So Charlie, how do we write 3x as being multiplied together?
X cubed.
That's right. And 3y's multiplied together?
Y cubed.
That's right. So it's x cubed, y cubed. Very good. So now we'll go to this next one, xy cubed. Now be careful here. See, the exponent over here is only applied to the y. The y is the base. That 3 over there in that exponent does not apply to the x. It's x times y cubed, which means x times y times y times y. Okay? So pay attention to what your exponent is being applied to. Remember, it's the base. You've got to define that base here. Okay, let's do another one here. This is a rational expression. Xy cubed over z to the 5th. Now, realize that exponent right there, that's on the y, which is a 3, means how many y's are being multiplied together, Charlie? 3. That's right, 3 of them. And how many z's in the denominator are being multiplied together?
5.
That's it. 5 z's. Okay, there we go. So let's move on here. Let's look at this problem here. -3 squared. Now realize here, the exponent is a 2 and the base is only a 3. Okay? In the next problem, we'll do it with the base being a -3. So that exponent only applies to the 3's, Charlie. So pay attention to this. Write it down twice. You have -3 times 3. There it is. And notice your answer is a -9. That's right, -9. Okay, now let's look at this one. Now you see here, Charlie, in the parentheses is a -3, which means the base is the -3. Now, since you have a -3 being squared, that means what, Charlie?
Positive 9.
-3 times -3. And remember, in this case, when you multiply a negative times a negative, you get a what, Charlie?
Positive 9.
Positive answer. That's right. Positive 9. There you go. So there's a difference there. Next problem. Now here we have -2 cubed. -2 is our base. So our base, -2, our exponent is 3. What does that mean, Charlie?
-2 times -2 times -2.
That's right. -2 times -2. And what is it? -2 times -2 times a -2?
-8.
-8. You better be right. And that's correct there. Okay. Now here we go. Another type of problem where, again, we have a negative and we have a 2 cubed. Now, Charlie, in this problem here, what's the base?
2.
That's right. It's only the 2. That exponent only applies to the 2. Okay? So it's like -2 cubed. And we'll go ahead and write that out for you so you can see it's a -2 times 2 times 2. And Charlie, what's the answer here?
-8.
It's still a -8. Okay? This is a different problem, but they did have the same answer. So pay attention to what's going on here. Now let's go to another one here. Let's throw in some variables. Okay, here we have a -xy squared. Okay, Charlie, what's the exponent here?
2.
2, that's right. That is just too good. And now, what's the base, Charlie?
XY.
XY, that's very good. And the negative is out there, so there we have it. Negative XY times XY. Okay, that takes care of your exponent. Okay, pay attention to those parentheses there. Now, what does that mean? Remember, XY simply means X times Y. Okay, and so we'll go ahead and write this out. We have a negative X times Y times X times Y. Okay, remember, you can multiply in any order you want. That goes back to the commutative property for multiplication there. And so we can reorder these to make it a little bit clearer here. Negative X times Y times Y. And so, Charlie, what's our final answer there?
Negative X squared Y squared.
Negative X squared Y squared. Very nice. Let's move on. Okay. Now, let's look at some other problems here, some more rational expressions here. Here we have x to the fifth over x cubed. Now, a lot of you may have to, or maybe we're told that you have to memorize rules for exponents, but we're going to try to go for an understanding of why the rules for exponents work in the way they're presented. Okay, so let's look at this problem here. Here we have x to the fifth over x cubed. Now, Charlie, how many x's are on top?
5.
That's right. How many x's on the bottom?
3.
That's right. So remember, x over x is actually 1. So we're going to start canceling or reducing, however you want to look at it. So we're going to cancel 3 x's on top with 3 x's on the bottom. Okay. Now, Charlie, what's left on top?
2 x's.
That's right. Now, what's on the bottom?
1.
It's a 1. It's not a 0. Sometimes people, when they cancel all those x's, they put a 0 in. It doesn't make any sense. Remember, each time you're canceling an x with an x, you're creating a 1 over 1, okay? So basically what you have here is you have x times x over 1, okay, Charlie, and how do we write x times x?
X squared.
X squared. And remember, x squared divided by 1 is simply x squared. So think about it this way. There were 5 x's on top, 3 x's on the bottom, leaving you with 2 x's on the top. Just 2 of them. See? That is just too good. Anyway, let's go on here. We have x squared. And so let me make a note of your exponent rules. Now, some of you were told when you're dividing a rational expression like this, x to the fifth divided by x cubed, when you're dividing with the same base, okay, what do you do with the exponents, Charlie?
Subtract.
Okay, the rule says to subtract. And that makes sense because you get x to the 5 minus 3 power, which is x squared. So that's using the rule, subtracting exponents, okay? But if you have 5 x's on top and you have 3 x's on the bottom, you're going to be left over with 2 x's on the top. And we simply write that as x squared over 1. Okay, so let's look at it now. Here's another problem, Charlie. How many x's on top?
3.
That's right. How many on the bottom?
5.
Okay, so what that does, let's write it out. X times x times x on the top, and on the bottom, x times x times x times x times x. Okay, we'll cancel 3 x's on top with 3 x's on the bottom, leaving you with white, Charlie. How many x's are on the bottom here?
2.
There's 2 left over. And what do we put on the top?
A 1.
A 1. Very nice, Charlie. And so, what is our answer, Charlie?
1 over x
1
squared.
over x squared. Very nice, Charlie. Now, let's go back to our rules for exponents when you subtract. When you're dividing with the same base, you subtract the exponents. That gives you x to the third over x to the fifth equals x to the what, Charlie?
3 minus 5.
3 minus 5, which is x to the negative 2. Now that takes us into negative exponents. We'll talk a little bit about negative exponents in a bit here in this lecture. But notice here, x to the negative 2 is what we got when we subtracted the exponents. Well, here we had x squared. So that means that x to the negative 2 must equal what, Charlie?
1 over x squared?
1 over x squared. There you go. Okay? So let's step it up a bit.